Hello and welcome to lecture 4 on aero engine gas turbine cycles. If you recall, in last few lectures, we were discussing about the mechanical thrust developed by all engine components. We have realized what we are writing in terms of our thrust equation. Basically, it is representing thrust that is being generated by my nozzle. But later on, by doing the numerical, we have realized that thrust will be generated by all the components. Then we were discussing about the thrust requirement for the various operations. We have realized the maximum amount of thrust which is required, it is for the takeoff condition, because unless you are having sufficient amount of thrust, you cannot lift off your aircraft. If we look at say cruise condition where we are looking for minimum amount of thrust, during our landing condition slightly less than that of maximum thrust we are having. If we are talking about the military aircraft, the scenario will be different, where we will be having thrust requirement, that is what will be varying with the operations. Say we are doing say acceleration, deceleration, we are doing various kind of maneuvers, where my thrust requirement, that is what will be different. Then we started discussing about the thrust variation at constant mass flow rate condition. So, here if you look at what equation we are having, net engine thrust, that is what is given by mass flow rate into exit velocity minus flight velocity plus area into this pressure difference. So, here what mass flow rate we are considering, that is what I say as a mass flow rate for say the flow, that is what is going inside my engine. Now, let us try to recall what all we were discussing in last lecture. If we look at here, we see this thrust equation, that is what we have divided into 3 different terms. First, that is what is called say momentum thrust. This momentum thrust we are representing in terms of ma into V9. Same way here, if we look at the next term what we have, it is m dot into V infinity, that is what we say momentum drag or say ram drag. Then we are having the term, that is what is area into pressure difference, that is exit area into P9 minus P infinity, that is what we have defined as a pressure thrust. We have also introduced the term, that is what is called gross thrust. This gross thrust is nothing but the summation of momentum thrust and the pressure thrust. So, this is what is all fundamental we know up till now. In last lecture, as we have discussed, we were discussing about say my variation of the thrust assuming constant air flow rate or constant air mass flow rate. So, for that we have divided our thrust into 3 different terms. We say like pressure thrust, where we can see with the change of my flight speed, that is what is remains constant, and because of change of altitude we will be having different values of pressure thrust. When we are talking about the momentum thrust, this momentum thrust it is given by m dot into A into V9. Here if we look at, that is what is says my momentum thrust, that is what is dependent on my flight speed, and that is the reason why with the change of different altitude that value remains constant, because my mass flow rate, that is what is not changing. In the case of momentum drag or the ram drag, we can see it is directly in relation with my flight speed, and that is the reason why that is what is giving the linear relation between the momentum drag and my flight speed for different altitudes. Now, gross thrust we have discussed, that is what is the summation of momentum thrust and pressure thrust, that is what is represented here. Now, in terms of overall understanding, we can say my thrust or net thrust versus the flight speed, we can see here this linear or say straight line, that is what is representing my thrust, that is nothing but my gross thrust, and here downside, that is what is representing my drag. So, if we look at carefully for the lower speed, we can say my thrust will be higher compared to my drag. Once we will be increasing our flight speed, we will be reaching to the situation where my thrust and my drag, that is what is coming nearly equal to same, and that is what we say as a cruise condition. Here this is also been depending on different kinds of altitude what we are having. So, magnitude with the thrust, that is what will be varying with the change of my altitude. Now, this is what is a scenario, we can say it is an ideal condition, because what we know, my mass flow rate, that is what is a function of density into area into velocity. Now, when we say my density, that density, it is a function of pressure and temperature. Same way, V infinity, that is what is my flight speed. So, we can understand, if I am assuming the mass flow rate, it is constant, this is what will be the scenario. Now, let us try to look at when we will be having, say, there is a variation of air flow rate. In order to simplify the problem, let us assume my mass flow rate, that is what is varying linearly with my flight speed. Here also this total thrust or net thrust, that is what we are representing in terms of, say, my momentum thrust, momentum drag and my pressure thrust. So, just take your pen and paper and try to plot the variation of momentum thrust, momentum drag and pressure thrust. Let us see how you have understood this situation. Suppose, say, first we will be taking the condition, say, pressure thrust. Here we can say my pressure thrust, that is what is not depending on my mass flow rate. So, similar kind of situation we can put it here. It says with the change of altitude, my pressure thrust, that is what will be varying, but it is a straight line. Okay. Now, let us take, say, next scenario. We are having our momentum thrust. Here it is interesting to observe my momentum thrust, that is what is a function of mass flow rate and my exit velocity. This mass flow rate, as we have discussed, that is what is varying. Okay. If I say my mass flow rate, that is what is varying, it will be vary with my altitude also. So, if we consider this is a scenario, we can say my momentum thrust, that is what is varying linearly with my mass flow rate. So, this is what is a scenario. Now, with the change of altitude, we can say we will be having the variation of my density, we will be having variation of my temperature, we will be having the variation of our pressure, and that is how there is a variation in my momentum thrust. In earlier case, if we look at, this was a different scenario. Now, let us try with, say, my ram drag. The ram drag, that is what is a linear function, or it is depending on my mass flow rate of air as well as my free stream velocity. Now, this mass flow rate, if we consider, that is represented by density into area into velocity, and this velocity we can say that is what is my V infinity. So, under this condition, my momentum drag, that is what will be different. See, in earlier case it was varying linearly. Here in this case we will be having this variation in quadratic way, and with the change of altitude you will be having the change of ram drag. It is shown like this. Now, let us try to put my total or say by gross thrust. So, my gross thrust, that is what we can represent for different altitude. It is like this. Okay. Now, in overall scenario, let us try to understand the overall scenario. So, this is what is representing here. In this case, if you look at, this is representing my net thrust and this is what is representing my drag. So, compared to my constant mass flow rate condition, the scenario will be different, where we were having our thrust, that is what was coming to be constant. Here my thrust, my gross thrust, that is what is varying with my mass flow rate, and here if we change our altitude, we will be having the variation in a different way. So, just realize this is what is our actual engine scenario. So, now we are moving more towards the detailed understanding what is happening in engine in actual flight condition. Okay. So, let us see, this is what in comparison you can see. If we will try to look at the magnitude of this thrust, we can say here when we are assuming our constant mass flow rate condition, my thrust will be lower, and that is what was say constant with the flight speed. In the case of actual scenario or variable mass flow rate condition, my thrust will be having say higher magnitude and that is what will be increasing with the increase of my flight speed. And at the same time we will be having our cruise condition, that is what will be different. So, now you can say step by step we are moving towards the actual scenario. Let us try to understand the scenario here. What we see till now, what we were observing is say my mass flow rate, that is what is entering inside my engine with v infinity velocity, and that is what we are defining as say mass flow rate to be m dot a. Now, in actual condition what is happening, say the flow, that is what will be getting compressed in my compressor. So, when I say compression, it will be increasing my pressure as well as temperature. If I say my pressure and temperature, that is what is increasing, I will be supplying that high pressure and high temperature air inside the combustion chamber, where I will be adding some amount of fuel, and that is what will be subjected to combustion at constant pressure. By adding this fuel, I mean we are increasing the energy contained of our working fluid. Now, the working fluid will be mass flow rate of air plus mass flow rate of fuel. That is what will be striking on my turbine, and this turbine will be rotating. That rotation of turbine will be rotating my compressor. Now, after passing through number of stages for the turbine, we will be having there is a reduction of pressure, because we know the process which is happening inside the turbine, it is defined as an expansion process. Now, after that it will be entering inside my nozzle. So, my exit mass flow rate now under this scenario, that is what I will be writing as m dot a plus m dot f, and this I am representing as m dot a into 1 plus f, where f we are writing as say fuel air ratio, mass flow rate of fuel divided by mass flow rate of air. So, now onwards as and when we will be writing this equation, here in this case we were assuming our mass flow rate at the entry and exit to be same. Now, onwards this equation, that is what will be slightly modified in terms of 1 plus f. Now, if we will try to analyze this equation, what we realize, it says like my thrust force, that is what is depending on my inlet mass flow rate. It is also depending on what is my outlet mass flow rate, what will be my fuel air ratio, flight speed, my exhaust speed and exhaust pressure. If you consider this area, I can say at this moment my area of the nozzle, that is what is constant. The scenario, it is changed now. We will be having say variable area nozzle. Number of engines which are available, they are having now variable area nozzle. Mainly for the fighter aircrafts, this area A9 what we are discussing, that is what they will be varying as per the requirement. So, in the next week when we will be discussing about the performance of different components, that time we will be touching this part. Now, here in this case, let us consider say my inlet mass flow rate condition. What we know, this inlet mass flow rate, that is what is affecting both my momentum thrust as well as my momentum drag. Now, if we look at carefully my inlet mass flow rate, that basically depend on what is my flight speed, what is my ambient pressure and temperature, what is my humidity, altitude and what will be the rotational speed of my compressor. So, we can say my entry mass flow rate, that has influence on both momentum thrust as well as my momentum drag. Now, if we will try to analyze in a different way, suppose if I consider I am having say outlet gas mass flow rate. So, here this is what is my outlet gas mass flow rate. We know that is what is depending on the amount of fuel we will be adding in our combustion chamber. There is one more formulation, it says air bleeding. We will be discussing this in detail for the special cases. This air bleed, it is nothing but taking out the air from compressor at some location for different purposes. The purposes include the cooling of my turbine blade. It may be required to pressurize the cabin. For that, there are many auxiliary devices which are available in the aircraft. They can be actuated by using this compressed air, and that's the reason we can say this bleed air, it is nothing but it will be reducing the amount of air that's what is going inside my combustion chamber and my turbine. At the same time, we are having the water injection. This water injection that is having a purpose. So, we will be discussing today what is the use of this water injection. Now, my pressure thrust, that is what is mainly been depend on my what is the turbine entry temperature, flight altitude, what will be my area and pressure. So, this momentum thrust what we are discussing, we know that is what is a function of my nozzle jet velocity. Now, let us try to analyze in a separate way what we can say, what all are the factors which are affecting the thrust. That is what it says my jet nozzle, it is in terms of my exit area, exit pressure, exit velocity, what will be my flight speed, what will be my mass flow rate, altitude and ram effect. So, let us try to analyze one by one. Let us take the first case, it says my jet nozzle. So, here if you look at this jet nozzle, basically it is affecting on two parameters. One, it is my pressure thrust, we can say it is my exit area and the pressure at the exit. At the same time, other term, that is what is my V9, it is my jet velocity. Okay. So, under this condition, if you will try to look at, suppose if we consider this as an engine, I will be having my nozzle, that nozzle is of conversion type. There are engines in which we will be having not only conversion nozzle, but they are using conversion diversion nozzle. We will discuss this in the next week session, but at this moment just realize we are having say conversion nozzle. So, conversion nozzle means my entry area is larger and my exit area, that is what will be smaller. You can say in the flow direction my area, that is what is reducing. Now, this nozzle that will be acting under choke or unchoke condition. What we mean by choke condition is, my maximum acceleration that is possible is m equal to 1 condition, that means my sonic condition. If I say my sonic condition, the scenario is beyond which we will not be able to increase the further mass flow rate. Okay. So, this also we will be discussing in the next week session, but at this moment just realize we are having the scenario in which my nozzle will be choke or unchoke. Now, when I say if we are looking for say exhaust pressure or say when we will be having our exhaust pressure, that is what is greater than that of my say ambient pressure, we can say that scenario as my choke nozzle condition. Under this condition, what we know, my pressure term, this P9, that is what will be greater, that means my pressure thrust, that is what will not be non-zero valued, it will be having some magnitude. So, you can understand if we would like to increase our thrust, we need to have the scenario where our nozzle need to be choked. So, if we are choking our nozzle, that means we are increasing our thrust by increasing the pressure thrust. Suppose if I consider the scenario where we will be having unchoke condition, under this condition my jet velocity, that is what will be varying with my atmospheric pressure. And there is a scenario where we will be having P9 equal to P infinity, that is what is known as a perfectly expanded nozzle. Under that condition we will be having our pressure thrust, that is what will be 0. So, you can understand when I say jet nozzle, it is mainly been affecting two parameter. One, it is my nozzle velocity, and second, that is what is my exit pressure. Okay. I am sure you will be having the understanding here. So, there are different terminologies which we will be discussing in next week. Here it says if I will be having my exit pressure greater than that of my atmospheric pressure, we can say my nozzle is under expanded nozzle. If my exit pressure is lower than the atmospheric pressure, we can say it is over expanded nozzle, and when we will be having this both the pressure to be same, we say that as a perfectly expanded nozzle. Now, after this, if we will try to look at the next parameter, what we have is my air speed or flight speed. So, this is nothing but the speed at which my air is approaching to the engine, we can say it is approach speed. That's what is equal to, we can say it's a flight speed. If we consider this as our formulation, and if we say my V9, that's what is constant, and if we consider say my V infinity, that's what is increasing. So, here in this equation, if we look at my V9 is constant, and if I am trying to increase my V infinity, that will lead to reduce my thrust. Okay. So, here in this case, if you look at with the increase of the flight speed, we will be having the reduction of our net thrust. And if we look at when we are having the altitude, that's what is changing, we will be having the change of net thrust accordingly. So, if my air flow rate and fuel air ratio, if both are assumed to be constant, we can say my flight thrust, that's what will be varying linearly in the terms of my air speed or the flight speed. So, this is what is very important for understanding how my thrust it will be getting affected with the flight speed. Now, the next terminology as we have discussed earlier is in terms of my mass flow rate, and if we consider the mass flow rate as we have discussed, that's what is depending mainly on what is my temperature and pressure, and how this temperature and pressure, that's what will be affecting my density, because my mass flow rate we are defining in terms of density into area into our velocity. So, if we consider say variation of my pressure, then you can realize if we will be increasing the pressure, we will be having the rise of my thrust. What we know, when we are moving towards the higher altitude, my pressure, that's what will be going lower and lower, and that's what will be lowering my thrust generation capacity. At the same time, if you look at the temperature, so what we know, my temperature and pressure, that's what will be varying in a systematic way. If we consider if my temperature, that's what is increasing, that's what we will lead to decrease my density, and that's how my mass flow rate, that's what is varying. And because of variation of my mass flow rate, my thrust, that's what will be reducing. So, here in this case, if we consider, it says my engine, if it is having the thrust capacity of say 10,000 pound, and if it is working under hot day condition, it may be generating 8,000 pounds, or if it is working under the cold scenario, then it may be producing the thrust in the range of 12,000 pound. Here we need to realize very important consideration. Let us take the scenario. You must have observed, many of you have now traveled through say aircraft. So, what is our common observation is, say we have seasons like winter and summer. If you look at the rates of my flight, that's what will be lower in the case of winter season. This is just for the understanding. And in summer, what we have, our flight cost, that's what is higher. And if you look at inside the flight, you will realize during winter season, the whole flight it is been occupied by all the passengers, and during my summer condition, you will see 20 to 30% of flight, that's what is empty. It is not because the flight cost is higher. This is been done purposefully by the airline companies. What is the reason? You can correlate what we want to discuss here. This is what is directly in relation with the temperature. So, what we realize, my thrust, that's what will be generated in my summer, that's what will be lower because of high temperature and lower density. So, in order to compensate for that loss of thrust, the capacity of this aircraft, that's what they are reducing. At the same time, during the winter, we will not be having this kind of scenario. So, ultimately you need to divide your cost of flying in terms of total cost, and that is the reason why your flying cost, that is what is different. So, I am sure after having understanding of this, you must be observing that if you have not observed till now. Now, the scenario is, if this is what is a condition, then airline company, they will be going in loss, and they are looking for the special kind of alternatives. So, if you stand near the airport and if you look at, you will see they are throwing some amount of water at the entry. It is not for the cleaning purpose, be careful, it is for the special purpose. Basically, they are mixing alcohol with water, and that is what is being ingested at the entry. When we are ingesting that, that is what is increasing my density of the air. And when we say we are increasing the density of our air, it means now it is giving what thrust we are looking for. So, just look at, this is what is a scenario. It says this is when we are having, say, temperature effect, the thrust, that is what is generated. By water injection, we are increasing the temperature limit. Same way, this is what is for, say, turboprop engine. You can see we are able to extend the shaft power developed by the engine. So, mainly 30% of mixture, mostly methanol, these people they are adding with. Now, this alcohol what we are using, that is what is having, say, anti-freeze property, and that is what will be also acting like an additional fuel. Okay. Now, let us try to look at what is happening with my altitude. So, again and again we are discussing about the international at standard atmosphere, and what we have realized, it says like at particular height the drop of temperature. So, here if you look at, this is what is representing the variation of my thrust with the altitude, and if you look at carefully, it says up to 11,000 meter or 36,000 feet we will be having the variation of the thrust. That is what is in, like it is not changing drastically, but beyond that it is changing drastically, and here it says this is what is representing the optimum altitude for long cruise. Here what is happening, my temperature stop falling and pressure, that is what will be dropping very fast. Now, if we try to understand the scenario, what it says, in this condition, like most of the flight what we are observing, say long range flights, these long range flights they are flying at the altitude of 36,000 feet. So, now onwards when you will be sitting in the aircraft, the pilot will be announcing, and just try to understand what is the reason, because we will not be having the effect of drastic change of my pressure on the thrust generation. So, this height it is been distributed among the airline companies in order to achieve the best performance by the engine. Okay. Now, let us try to look at the next term, that is what is called ram effect. What we mean by ram effect? When we say my aircraft that is what is flying, it means my increase of flight speed, that is what will lead to increase the amount of air, that is what is entering inside my engine, and that is what will lead to increase my gross thrust. Now, this what we are discussing, it is not that easy, because when we say ramming effect has two factors. One, it is increasing the air speed, and second, it is increasing the pressure, and that is the reason why it is increasing the amount of air going inside the engine. Now, what we have realized, we say by increasing the flight speed, we will be having the drop of the thrust. If this is the scenario, you can say like my flight speed, if it we are increasing, the thrust will be reducing, even though we are flying, we are trying to fly our aircraft at the high speed. What is the reason? Now, at the same time as we have discussed, we have second parameter, that is what is called increase of mass flow rate, and that is what effect is known as a ram effect. So, if we will try to adapt these two effects A and B, you will be getting this C as your actual engine condition. So, what is the meaning of this C? It says like we will be having the thrust, that is what will be reducing with the increase of my flight speed, but because of we are getting the benefit of ramming effect, that is what will be trying to compensate for the loss of thrust because of increase of speed. So, most modern subsonic jet power flight, they are flying at higher altitude and they are flying at high subsonic speed. in order to take the benefit of ramming effect. So, if you will try to look at the numbers, it says my aircraft, high bypass ratio engine aircraft, they are flying at say Mach 0.8 or 0.85. Now, if we consider the next, we say the factors which are affecting the thrust, these factors we are correlating in terms of factors related with my engine and factors which are related with the surrounding medium. When I say it is related with the engine, then straightway it says what will be the rotational speed of my compressor, because with the change of my compressor speed, we are changing our pressure ratio. With the change of my speed, the turbine work also will be changing. Second parameter, we say it is my exhaust nozzle size, that is what is influencing our jet velocity. The amount of fuel what we are adding, that is what is directly increasing the energy contained, and that is how my turbine entry temperature, that is what will be increasing. Now, compressor bleed, water injection and component performance, which will lead to increase the specific speed. So, if we look at carefully, this engine parameters, they are mainly been affected what is my air flow rate and the jet velocity. Now, if we will try to look at the second group category, it says what is my forward speed, that is what will be lead to decrease the thrust and more amount of fuel, that is what is going inside. The second parameter what we have, it is our density, and we have seen it is a function of my flight speed, humidity, hot and cold air, and that is what will lead to change the thrust as per the requirement. Okay. So, here in this case we can say we have tried to cover most of the content in terms of what all we have, what is the effect of different parameters. Now, let us take one tutorial problem. So, it says my aircraft, that is what is flying at 260 meter per second. The air it is ingesting with 50 kg per second. The ambient air pressure is 60 kilopascal. For 1 kg of air flow, it consumes 0.05 kg of the fuel. The exhaust area, it is 0.25 meters square, and the exhaust velocity is 500 meter per second with exhaust pressure of 120 kilopascal. So, we need to calculate what will be the pressure thrust, momentum drag, gross thrust and the net thrust. So, this numerical, that is what will be giving the overall idea about how these parameters we are calculating. So, here we are stopping with this session, and let me try to compile what all we have discussed today. It is in terms of variation of my thrust with change of mass flow rate. We were discussing about what all are the parameters which are affecting on say performance of my engine in terms of thrust. We have discussed about the jet velocity, we have discussed about the effect of mass flow rate, effect of flight speed, effect of altitude, effect of ram effect, and all these parameters we are discussing in terms of engine parameters as well as the atmospheric parameters. Thank you very much for your kind attention.